everybody, and welcome to section 6.13, which is on energy conservation. Today, your learning objective is that you can describe methods for conserving energy. Some of the essential knowledge that you're going to gain is various methods that can be used for conserving energy on a small scale, like individually at your own home, and then on a large scale for like an entire government or country or area. So we're going to talk with some of the small scale versus large scale methods for energy conservation. So some of the small scale ones on the left-hand side here is doing things like lowering your thermostat to use less heat or using the AC less often, because heat and cooling is going to be a large form of energy use within a household. Other things that you can do is conserve water, because actually getting water to you takes a lot of energy in order to pump it and treat it and heat it. So if you conserve water with things like native plants instead of grass, having low flow shower heads, efficient toilets, dishwasher, and dryers, this is going to be another way that you can do better with energy conservation. And then also having energy efficient appliances and a better insulated home to keep heat in and to just be more efficient with energy usage. For some large scale things that can be done on a more like country level, on the right-hand side here, are doing things like improving fuel efficiency standards. So instead of having the standard for fuel efficiency getting 20 miles per gallon, if you get 30 miles per gallon, then that's going to be less gasoline that cars are going to need to get by. Governments can also subsidize by giving rebates or tax credits for electric vehicles, or for companies making charging stations or having hybrid vehicles. And then also giving increased access to public transportation, like buses and light rails, and then having green building design. So let's look at some sustainable home design options that we have. And this is going to be ways to either block out or take advantage of the sun's natural heat, or in keeping our heating and cooling to decrease energy required. So one method that can be done is using deciduous shade trees for landscaping. And these have leaves during the summer, which are going to block sun and keep a house cooler. But then during the winter, these trees are going to lose all of their leaves. And so you're going to have more sunlight coming in during winter to help warm up the house so that you don't have to use your heater as much to do that. Another option would be using passive solar design concepts to trap the sun's heat and decrease energy from the heating systems. Things like heat absorbing walls or having double paned windows are going to be ways that this can be done. And then also having well insulated walls or attic in order to trap in the heat during winter and to trap in cool air from AC systems during the summer, so that you don't have to just keep running the AC continuously, but once you cool it, it'll actually keep the cool air in. This is going to decrease the electricity that's used by the AC units and the energy that's used to heat during those cooler months. Now, water conservation, as I said, it takes a lot of energy to pump water to your homes, to heat it, to treat it, to move it. And so water conservation is going to be good just for water conservation, but then also for electricity. So some ways that you can conserve water. The first is going to be with landscaping. Instead of having grass, which takes lots of water to keep green, especially in like desert areas or even here during the summer, you have to have your sprinkler going a lot in order to keep this green grass. So instead, you can plant native plants, which are actually meant to live in our area with our climate during the summer with less water. And so you don't have to be watering it continually in order to keep them alive and looking beautiful. It's also going to a lot of times have flowers. So this is going to increase our biodiversity. It's going to be great for pollinators like the bees. And also green grass usually requires fertilizers. And so you don't have to be spraying it with all these chemicals in order to keep the grass and keep the weeds out and keep it green with water. Just like have some dirt and plant a bunch of pretty natives and give the pollinators pollen and use less water. Another option within the home is having things like low flow showers. You can literally just replace the cap on your shower so that it has less water coming out of it I promise when you're taking a shower, you literally won't even notice a difference, but it's going to make it so that you're using less water. You can also have toilets that use less water every time you flush them. You can have energy efficient dishwashers so that they're using less water. So you're able to still do all the same things in your house. You're just using less water, which again is going to require less energy to purify and pump this water to your house. You can also use things like rain barrels, which are legal in Washington. Some states it's not legal. But here in Washington, you can use rain barrels. And so these are things that you have under your gutters and your rain drains. And so it's going to collect all of the tons of rainwater that we get here in Western Washington, and you can store it, and you can actually use this water to water your plants or wash your cars. Don't use it for drinking because you got lots of weird chemicals that can potentially come off your roof. Maybe don't use it in vegetables gardens, even though a lot of people do. But especially for just like watering your plants or washing your cars, you can use this. And then that's more water that you don't have to have coming out of your hose and faucets. And then a big area where we can have energy conservation is going to be transportation. In 2019, about 28% of the total United States energy came from transporting of goods and people. And so one of the things that we can have our government specifically do is improve the fuel economy of our entire like general US fleet of vehicles in order to conserve energy and use less gasoline and diesel in order to travel. So there's this thing called CAFE, which is the Corporate Average Fuel Economy. And these standards and regulations are set in the United States by the government, and they can require auto manufacturers to make cars that meet certain mile per gallon standards or pay penalties if they don't. And so if you look over time, as the government has become more strict with these regulations, the average car is becoming more and more efficient with its miles per gallon over time, for all of them. Like this is looking at domestic cars that you and I drive. It's looking at like trucks and import cars. And so over time, as the government puts more stricter regulations, then the car companies actually have to make cars that are going to meet better miles per gallon standards. So this is something that the government can impose that then makes our transportation more energy efficient. We also are going to have cars that are hybrids. The Prius is a great example of this. They have both a gasoline and an electric engine, which makes it so that they have way higher miles per gallon because you can use both. You can use the electricity before you get to the gasoline. And so you don't need to have, you're going to have way higher amounts of miles that you can get out of a single gallon of gas. Now, in a typical system, you do have some hybrids where you actually plug them into the wall, but you also have a lot of them where the braking system is actually what charges the electric battery, which is very cool. And so it's going to help power that electric side of the motor, and you don't even have to plug it in and use that electricity to make this happen. There are some downsides with the like batteries, but overall, this is still going to be way better than your traditional gasoline engines where it's just gasoline powering it. And then you can even have purely electric vehicles like the Tesla or the Nissan Leaf, which don't use any gasoline. But something that's important to keep in mind is that they do still require electricity. So they're only as sustainable as the electricity source they have. So if you've got a house with solar panels, this is awesome if that's what's powering your Tesla. But if you are going to be on a power grid that is getting most of its electricity from fossil fuels, then fossil fuel production is still going to make it so that your Tesla is maybe not as sustainable as you might think, even though it is not using the fossil fuels for gasoline. So it's still a step up, but still keep in mind, it's only as good as your electricity sources. The actual like best, most energy efficient form of transportation is going to be using public transit and doing carpooling. So that's going to actually be like the best option, especially because nowadays a lot of our buses are actually going to have zero emissions. And so they're going to have these electric buses that carry hundreds of people or at least hundreds of people a day, maybe not in a single bus, but either way, it's going to be way better than having thousands of little Teslas out there. So if you are wanting to do the best you can, use public transport or carpool. Now, another thing we can do is sustainable building design. And this is where you're going to be decreasing the amount of energy that's required to build larger buildings. So not like individual homes here, but if you're thinking more urban areas where you've got skyscrapers full of buildings, using sustainable building design practices are going to make an impact on these. So one thing that you can do is have what's known as a green roof or a green wall. And that's where you just are going to be growing plants either on the roof or on the side of the building. And this can help with decreasing runoff, but also it can absorb the sun's heat, which is going to decrease the energy needed to cool the building and the surrounding areas, which is going to lessen this heat effect. You can also have skylights on your roof or windows on the side to decrease the electricity that's needed for lighting, at least during the day, so you don't have to have your lights on all the time. And additionally, we can use things like recycled materials in order to produce all of the building materials. So the glass, the wood, you can even use ash from coal in order to make new foundations. So by recycling these things, that's going to be decreasing not only the materials that we're needing, but also it's going to be decreasing all of the energy that goes into producing them. So using recycled materials, it's going to be a sustainable building design choice. Now, power companies do something where they manage peak demand. And peak demand is going to be the time of day or year, which is often going to be your nighttime hours or when we have very hot weather, that electricity demand is the highest. Now, a big problem is when you have a ton of people needing electricity at the same time, if your demand is going to exceed your supply, you're actually going to have rolling blackouts where people lose power because the power company literally cannot produce enough electricity for them, which is obviously not going to be good for a utility company. So some utilities, in order to manage peak demand, use what's known as a variable price model for electricity. So they actually charge more for the electricity at certain times of the day. So like between the hours of 5 and 9, a lot of times utilities are going to cost more than they would in the middle of the day. So users are going to have to pay a higher rate during peak hours in order to discourage their use. So for example, this would be a graph showing a Texas electricity rate comparison. A variable rate is going to be where they are going to increase their costs either at a time of day or even a time of year. So for example, in Texas, August is going to be the hottest time where a lot of people are going to be running their AC. So this local utility company will actually increase the prices to make it so that it costs people more, which is going to deter them from using it. So this is going to incentivize it so that they have a lower overall use because they're going to pay less when they use a lower amount of energy. And sometimes hitting people in their wallets is the only way that you can get them to make different choices. They will also look into having more energy efficient. If they're paying tons for their electricity bill, they might start swapping out for LED bulbs or for more energy efficient things. When I bought my house, we got our first utility bill, and let me tell you, we moved up our priority to swap out for energy efficient options. We got our house insulated, we swapped for all LEDs. We eventually wanted to do it as environmentalists, but as soon as we got our first bill, we wanted to do it immediately because it's expensive. And so sometimes this is a way that utility companies get people to swap for more energy efficient options because it costs them a lot. And this will deter their overall usage, especially in times where a lot of people are using electricity and these companies are worried about these blackouts occurring because they don't have enough electricity to supply the demand. Now, companies can also use what's known as a smart grid. And this is kind of like a philosophy. And a smart grid is going to be the idea of managing demands and energy sources in a more varied way. So if you look at this diagram here, on the left-hand side might be more of our previous. You've got a few large power plants that are centralized, and then you're going to be using pipelines or batteries or large power lines in order to send all of this electricity to people that are paying for it. In a smart grid system, you're going to have kind of a more varied, holistic way. You're going to be using smart meters so that you can have variable price models. You're going to have rooftop solar to where it's not just all coming from producers to people, but like you can have people that have solar roofs on top of their house that are actually giving back to the electricity grid. Instead of having a few large power plants, you can have a wide variety of more renewable resources, such as using like hydroelectric power or solar or wind. Maybe each of these individually aren't going to be enough to supply, but all together they can, and they're going to be kind of more spread out. You can have individual communities that are having their own little solar farms instead of one big power plant, only a few of them per state. And so you're going to have more like total energy sources, especially renewable ones. You're also going to give this out to individual people. So this smart grid is kind of this idea of this like more of a grid that people are contributing to, and you're having it decentralized. And it's not as traditional as just like our few coal plants just ending up straight at the person. So this is going to be kind of a more like spread out option for being more varied and more smart in your electricity production and usage. So this is going to be your practice FRQ for 6.13, and you are going to practice the suggestive skill of doing some actual calculations. So I want you to look at this graph here, and I want you to calculate the percent change in global investment in renewable energy from 2004 to 2014. So make sure that you're first starting with reading the graph correctly and then calculating the percent. And I realize with a graph, get as close as you can with the actual numbers. As long as you're close, hopefully your calculations will still be kind of in the range of where they need to be. But look at the graph and then calculate the percent change. So that was going to be your practice FRQ on 6.13. Those are your notes on 6.13. And I hope that you learned about a lot of cool strategies from these notes.